Post-implementation review project, final presentation, Axiom Patient Access at the University of Minnesota School of Dentistry by Carly Sturm, Jenna Murney, Madeline Sturdivant, David Bowles, Lee Tan, and Casey Gray. Axiom is a cloud-based software as a service that is commercially available for purchase through Exan Group. The software is tailored to provide standards of care for patients and make data-driven decisions for academic dental institutions. Patient Access is a module of Axiom where the patient is able to view and confirm appointments, complete forms online, securely message their dental provider or billing representative, and view their health summary, including all of the treatments they have had at the University of Minnesota School of Dentistry clinics. Patient Access and the Axiom software is designed for patient and clinic efficiency, student management, and business administration. After registering for Patient Access, patients are able to easily access their dental healthcare information from the University of Minnesota School of Dentistry clinics. Axiom software provides different features to improve patient care and clinic operations. One example would be the ability to record, store, and access a patient's clinical activity in one central location. Among many other features, Axiom is able to customize the software based on the needs of the organization. The Axiom software is HIPAA compliant and certified by the Office of the National Coordinator, authorized testing and certification body, which is the main certification authority for electronic health record technology. According to Exan, over 90% of North American dental schools use Exan software. Axiom is revolutionary academic dental software that helps provide a high-quality learning experience that will be beneficial to students as they work towards their degrees and move into their careers. The definition of technology environment is a secure environment that is maintained primarily through role-based separation of duties, as well as a small number of administrators. Axiom has a long-lasting security policy which includes passwords and audit logs, so many high-security issues are prevented. All university infrastructure, including patient records, are secured behind multiple firewalls and housed at an enterprise-class data center. All information for each user is only visible by the user and the medical professional. All information is secure and details are protected and encrypted. Axiom's system is an audit history for users. This gives the administrators power to see any changes that were made and by whom those changes were made. Axiom's system can run nightly backups. An integrated automated backup solution allows for constant monitoring of operation backups. System maintenance is performed by the Axiom vendor, and they send out upgrades each year. The internal policy is to wait approximately 6 months before install. This helps to ensure the very best user experience as multiple fixes will be released as a patch during the time lapsed. Tracking hardware components for the University School of Dentistry is handled by another department, the Academic Health Center. Some of the developmental policies and procedures include service level agreements with external vendors, being a part of the governmental request for proposals, policies designed to keep patient information confidential, and procedures in place that prevent barriers in receiving dental care. The IT director met with stakeholders to gather business requirements for patient access. These included the ability to schedule appointments and communicate with providers online. Management and staff also gave input for requirements. The communication plan was designed to manage all communication via presentations, meetings, emails, and messages on the Axiom program. Decisions were made by a committee in the best interest of the school and of their patients' healthcare. They decided that Axiom was more affordable than other programs and that applications going in the cloud storage would result in lower costs and easier usage. The IT department and various committees were responsible for requirements and changes. Advertisement was used through emails, flyers, and posters. Axiom had test runs for mock usage before it went live. The AHC managed university server and database, and minimal training was required to install and use the software. Axiom's patient access rollout at the University of Minnesota School of Dentistry was successful in its implementation, but not in advertising. The purpose for the application upgrade to allow online scheduling and secure messaging was met. However, usage metrics did not meet expectations. The application module, Patient Access, fulfills meaningful use criteria for the Medicare and Medicaid EHR online incentives program. Successful adoption improves the efficiency of patient care and lowers clinic costs by streamlining efficiently. Technology development is the value chain activity it adds to the business of dental chart software, which is a focus strategy. Dental IT is enhancing their activities as part of a broader effort to accelerate the adoption of health information technology and utilization of qualified electronic health records. Our recommendations are to improve usage, a combination of advertising new features and making the product easier to use for laypersons, rolling out First Access, which is a related module that allows people without smartphones to log in at kiosks in each lobby, standardizing the data because many brands are used in different offices of private practices that aren't compatible with Axiom. A module would allow different interpretations for each. The school takes part in many research projects. Currently, each project is managed individually by staff members. To address growing needs, we recommend the development of a clear process for researchers to have a channel where they can make data requests. And dental IT can reduce maintenance costs by becoming optimized for remoting into a server-based computing environment. Additional benefits include hardware resource optimization, reduced software maintenance, and improved security. The data sources that we used for this project included the initial interview with Rich P., who is a supporting technician of the dental IT department, annual budget reviews released by the University of Minnesota Board of Regents, company-wide internal memos, and business periodicals. As a group, we learned that we have socially shared cognition, that individual performance can improve if each person is allowed to focus on what they're good at, and that we actually may deepen our understanding of a particular subject area this way. We learned interpersonal skills such as speaking and listening, as well as teamworking skills such as leadership, working with and motivating others. We enhanced our self-awareness by identifying our own strengths and weaknesses, and we learned to effectively communicate via the internet.